We've been talking about and looking at examples of problem solving, but problems and problem solving are only part of what you might do in a maths classroom. They're part of a spectrum of different types of activities and different types of assessment. So at one end we've got exercises. The thing that defines what we mean by exercise is you've got a good idea of the answer that you're trying to find. And also when you're approaching it, you have a good idea of what technique, what approach, what method you're going to use. And typically these are taught as part of the lesson, and then the student is supposed to reproduce these either in exercises or in assessment. As an example, let's look at quadratics, something which often appears in secondary school mathematics. So in a class in which quadratics are being discussed, a teacher might stand up and say, well, if we've got an equation like this, ax squared plus bx plus c equals 0, then the solution is found using this formula, x equals minus b plus or minus square root of b squared minus 4ac, all divided by 2a. And then the process of working these exercises is to fit each problem into this template and to use the formula to pop out an answer. Just plug in the components as you see them in the exercise. So we can do that. Now if the student does it correctly, they of course get the big red tick which says yes, work well done. If they're actually looking to take this a bit further, then I guess the student can demonstrate that they understand what it means to solve an equation, and by this I mean that the answer they get at the end actually works in the original equation. This is what we mean by solution. So we could plug those numbers in. Of course, once one of these is successfully done, then what's next? Well, you do another one, then you do another one, and so on until you run out of time in the class, or that you're sure as a teacher that every student has grasped the technique, how to use this equation, the quadratic formula, to solve quadratic equations. So this is typical of an exercise. We've got a particular well-defined type of question, and there is a well-defined procedure to follow, out of which comes an answer. And once you've got that technique under control, it's fairly mechanical. Now in contrast, if we're looking at problem solving, well, what do we mean by problem? It's something where, in contrast to exercise, we don't know what techniques or approaches that are going to be used. We don't start off knowing that. We might have some ideas, but these aren't there in the question. We may even not know what type of answers that is expected of us. We might not know our goal. So this can be confronting, but I guess the good news is that it's up to us to decide that in this course of our problem solving. So it's up to us to decide what's an adequate resolution of the problem. And it's also up to us to decide what techniques we're going to use, and also just the attitude we're going to take to investigating this open-ended, unknown problem that's been given to us. So the nature of problem solving is that a student needs to actually become personally engaged in decision making as to what it is they're doing. They can't switch off, they need to think, investigate. It makes it more difficult to learn and more difficult to teach, but it's also more engaging and rewarding. The other thing to note is that problems and exercises, it's a spectrum, and where things fall on the spectrum, a particular question, a particular activity, depends on the resources that the learner, the student, is bringing to the class. For some people, solving a particular type of problem might be an exercise because they have the skills for it. For others, it may be a problem because they really need to actually find out how the question works. What are the principles behind it? What makes it tick? Now you might think that problem solving is the thing that you do right at the end of your mathematics education, where you have everything under control, where you have all the skills that you can apply to be an expert in problem solving. And some of you may think you'll never get to that part of your education. But in fact, if you look at how the mathematics syllabi around Australia are framed, you'll see that problem solving is something which is ingrained throughout every stage. The principles and processes in mathematical problem solving are common to inquisitive children, students studying mathematics, and professional mathematics researchers. So mathematics problem solving occurs at all levels of mathematics. In each case, there is something common. There are the processes and principles, but there's also the drive to discover something new. So really, this attitude towards problem solving is what drives us in our problem solving. Are you going to have a go? Are you actually going to dive in, try stuff out, leap into the unknown, stuff you don't know, stuff you haven't seen before? We will see as we go through this course that this process and willingness to engage in problem solving can be seen as a form of really deep engagement with our content, with our mathematics. It can be readily identified as having the attributes of what we call deep learning. We are investigating, we are looking for the reasons behind the things we're studying, we're looking at the rationale for studying these topics in themselves. And how do we get there? How do we get to be problem solvers? How do we get to be good at this process of diving in? Well, we need to have experience. We need to practice, and we need to get our hands dirty and solve some problems. And we also want to become practiced at reflection. We want to reflect on what works for us when we're solving problems, why it works, and how do we incorporate what we have learnt from our problem solving into our knowledge and our experience that we can then use again the next time we're solving problems. So just some quotes from the literature. Lester, a publication in 1983, states on this note about practicing, you must solve lots and lots of problems in order to improve your problem solving ability. Secondly, Lester says problem solving ability develops slowly over a prolonged period of time. So in this course, Thinking and Working Mathematically, we want to give you a start, to put you on the right track, to demonstrate to you what problem solving is, to give you some experience and some confidence in your problem solving ability. And thirdly, Lester notes, most people will benefit from a systematically planned approach to problem solving instruction. So in this course we will be seeing some of this structure, some of these different ways of systematically investigating problem solving in ways that will help your problem solving ability.